Make him feel welcome.
Hello, thank you everybody for coming along. This is the art and science of diagramming, or possibly how to diagram like a programmer. Who here would consider themselves a programmer or a developer? Good percentage of you. Who here is familiar with programming concepts? Pretty much everybody, right? So I've obviously got the right target audience, which will come in a little bit. So that's me. My name's Adam, and I have been in the diagramming space for something on 8 years now. I worked for about 5 years for a company that was doing process modeling, first as a consultant, then as a business analyst on the development team. I do come from a development background as well. Before I worked for them, I was a programmer. And now I work for a bank doing enterprise architecture. So I'm fairly familiar with how to do diagrams. Hopefully by the end of this you will be too. Just a little bit of a caveat. I will be talking today about how to make diagrams look good, how to make them presentable. I won't be so much talking about the content. So we're going to assume that the content of your diagrams is okay. We're just going to talk about how to make them look better. So, diagrams, I hear you say. Where I'm going, I don't need diagrams. Well, let me perhaps clear the air a little bit. Diagrams are a form of visual communication, and visual communication is used absolutely everywhere in our society. In pretty much anywhere you go, you will see some form of visual communication, and most of those are diagrams. Now, entity relationship diagrams, if you've ever used or programmed for a database or for a object-oriented programming language, you might be familiar with these. That's a kind of diagram. I mean, it's right there in the name, entity relationship diagram. Similarly, flowchart. If you haven't seen an entity relationship diagram, then perhaps you've seen a flowchart. And if you haven't seen a flowchart, how about something like this? That's a form of visual communication. And it's also a diagram. It's explaining to you what's happening on the road ahead without any words. So is that. So is that. So is that. So if you've ever seen any of these symbols, then you will have used a diagram. So the question, as my girlfriend is asking that, why, how do I make a diagram? Why are you talking about diagrams now? Just shut up and let's go to get some food. So when I'm talking about diagrams, I'm talking about things that that diagrams most commonly describe some sort of process. So you want to create something that shows people, say, how to use a piece of software, or how you anticipate the flow of somebody using something. Knowing that, the most important thing to keep in mind, and throughout all of this, is knowing your audience. You have to pitch these things to the people that you are attempting to communicate the information to. If you don't do that, then things are going to get lost in the clutter. And the other thing is, know the message that you want to convey. You've got to be on point. If you want to show somebody how to do a specific thing, don't go off on a whole bunch of tangents. Show them the thing that you want to show them. Now this guy here, he's a little bit of a hero of mine. He's called George Box. He was a British statistician. And to paraphrase a quote of his, which I really, really like using, all models are wrong, some models are useful. Yeah, what does that mean for us when we're talking about diagrams? Well, diagrams are a form of model. We are modeling a process or a structure for people to see and use. Now, the reason that this quote, all models are wrong, some models are useful, is important, is that it's easy as a programmer, if you've sort of got that mindset, you want to kind of describe everything that's happening and make the person that you're talking to want to understand all the nuances, all the options, all of that stuff. But if you keep this quote in mind, you realize that it's okay. You don't need to show all of that. You just need to show them what they need to see. So it's okay if it's wrong, as long as it's useful to the purpose that you're using it for. So I've come up with a little diagram here. This is something that hopefully everybody might be familiar with as well. It's a process for ordering a cup of coffee. Now, obviously, this diagram is not terribly good. I mean, sure, it's kind of pretty. It's sort of got like a little cup and saucer and coffee in the middle and things. But if somebody looks at that, they go, that's a mess. Where do you begin? What do I do? I mean, drink coffee is the main thing, maybe. It's big and it's in a different color and there's no definitive start point. That's not a very good diagram. So at this point in the talk, I'd like to interrupt and talk about ducks. So ducks are great, you know, they do lots of things. They can swim, they can fly, they can walk on the land, they can lay eggs. If you're into that kind of thing, they're pretty tasty. But one thing that ducks are not, or ducks can't do, is be a building. Yeah, weird, I know. Let me give you a bit of a quote to give you a little bit of context on that. So there was a book called Learning from Las Vegas, and in it, the author said, when modern architects rightiously abandoned ornament on buildings, they unconsciously designed buildings that were ornament. In promoting space and articulation over symbolism and ornament, they distorted the whole building into a duck. They substituted the innocent and inexpensive practice of applied decoration on a conventional shed for the rather cynical and expensive distortion of program and structure to promote a duck. It is all right to decorate construction, but never construct decoration. So, when you try to decorate, when you construct decoration, you end up with something like this, right? That's what they built. And, you know, it's not a very good building. It's a great duck, sure, but it's not a good building. I mean, you know, the roof, the exhaust, all the, look, there are heaps and heaps of problems with it. So what I'm trying to tell you here, with your diagram, don't build a duck, okay? Aesthetics, another way of putting this is, aesthetics are irrelevant, okay? The aesthetics come about, you get a beautiful diagram from making a diagram which is sublimely functional. So if you follow all the rules that I'm about to show you, you'll have a diagram which looks nice and works really well, but is not a duck. This diagram is a duck, okay? So going from this base, we're going to look at how we can improve this, make it better, and hopefully you'll learn a couple of interesting little tips and tricks along the way as well. So the first thing that we're going to talk about is modularity. Lego's great. It's modular. It all connects together. You've got little bits and pieces. You can arrange it in whatever way you want to present any kind of outcome that you feel like. Think about it like functions, right? Things that you are doing often, or you know, things that kind of don't really fit with what you're doing at the moment, you break them off into a separate function. So, and then you can call functions from other bits and pieces. And the other important thing to think about with this is when you have a function call, you can only enter that from the top of the function call. You can't go in halfway through. You can exit from wherever you like, but you can only enter from the top. Why is this important? Because if you have a diagram that's too big, then you exceed the cognitive bandwidth. So looking at, we'll talk about cognitive bandwidth in just a second. So looking at this, our target audience is a person who wants to order a cup of coffee. So what bits do we have here that kind of don't really belong? Well, this bit here, check for more customers. Person ordering a coffee doesn't want to look behind them and go, oh, are there more people there? They don't care, they got their cup of coffee. So we'll get rid of it. What other bits? Collect the coffee cup, wash cup, put it, no, don't need that bit either, but they're gone. We've lost some meaning in our diagram now, I hear you say. Well, yes and no, because what we can do is we can put these back in as exits to other diagrams, other functions. Still doesn't look great, but that's okay, we'll get there. Let's take a little bit of a break and talk about cognitive bandwidth though. So, like internet bandwidth, cognitive bandwidth is the amount of stuff that you can cram into a human brain at any one time before it kind of throws a bit of a fit and just doesn't want to work that well anymore. So with diagramming, cognitive bandwidth is very, very important because if you exceed the cognitive bandwidth of a person on a diagram, then they won't be able to process that diagram very quickly and efficiently. Sure, they can still look at it, they can examine it, go through it, and understand it, but that immediacy of understanding is lost. What is cognitive bandwidth? Am I just waffling about it? Am I just going to tell you in vague terms? No! I will give you a number. That number is 7 plus minus 2. So anywhere between 5 and 9 items on a page, on a diagram, is what you can have. But, there's always a but, there are ways of circumventing this, of increasing that number, and I will show you that in just a moment. We've got to go through a couple of other little hoops first before we can get there though. The next important point to talk about is consistency. I don't know if any of you knit or crochet, but tension is very important when you do this kind of stuff. And if your tension is all over the place, then you have some of these loops that are big and some of them that are small, and it doesn't look very nice and it'll probably fall apart. Another way of thinking about it, something that the programmers in the audience may understand a little bit better, is if you start writing a function in BASIC, say, and then halfway through you switch over to assembler, you're going to have a lot of problems. Most of your compiler is not really going to be able to understand it. People reading your code won't really be able to understand it. So what you want to do is create a consistent visual language for your audience to understand. It doesn't matter what it is, okay, as long as it is consistent and understandable by your target audience. Also, not something I'm particularly going to get into today, but it is also a lot easier if you use consistent labels and consistent names for your diagrams and for the steps in your diagrams. You'll see that on this diagram here, I've got, it's always your, your verb and then your noun. So it's action, thing. And that makes it a little bit easier to read as well. So the big problem that we've got here in terms of consistency is these two big blue boxes there. Why are they big? Why are they blue? Because duck, basically. So let's just make those consistent. Cool. Now let's talk about Discriminability. Okay? Can anyone tell me, is everybody here familiar with Ghostbusters? Yeah, okay. The biggest rule, the biggest warning in the Ghostbusters universe, what should you never do? Don't cross the streams. Yes, very important that, because crossing the streams or having arrows that cross each other makes it very difficult to tell where they're going. Are they elbow joints that are supposed to go off in different directions? Are they supposed to cross? So if at all possible, try and make your layout not have any bits that cross. Even if your arrows sort of have to take a roundabout way, fine. Make it so that they don't cross if at all possible. Sometimes it's not possible. In those cases, maybe try and do something like use one curved arrow and one straight arrow in order to make it a little bit easier to see what the arrows are actually doing. Another thing with discriminability is, does everybody remember those 1990s GeoCity websites? You know, where they had like the blinking backgrounds and the text that like faded into the background and things like, not very discriminable. Okay, you can't tell what's going on because everything is all, you know, popping out at you all over the place. So having a style where your background is nice and plain, and then the items that you want people to see coming off that page and being visible to people is a really good thing. Make sure the writing can be read. And the symbols, make sure the symbols that you use can be identified. You know, don't try and reinvent things if you don't need to. But the other thing is, try to make, if you are using different symbols, try to make them distinct. Don't have like, you know, a box with one rounded corner, a box with two rounded corners. Try and make them, okay, so I've got a box, I've got a circle, I've got a, you know, a cylinder, whatever. Make them distinct from one another. If they need to be distinct, make them very distinct. So, looking at our duck again, as an example, let's apply that don't cross the streams rule. We get something like that. Already you can see that's so much easier to read. You can tell it starts from there, it ends over there. Fantastic. But we can do better. Let's talk about the Gestalt law of proximity. What this law basically means is that if you put stuff close together, then people kind of see it as a group of things rather than as a whole bunch of individual things. So as you can see on the first bit there, they're all grouped together, it's one big clump. You separate them out, we've got 3 different sets of things. Now this is one of the ways that you can circumvent the cognitive bandwidth of things by grouping things into groups of 5 to 9 items on the page. People will kind of automatically look at those and go, that's one group, that's another group, that's another group, and it'll be easier for them to break down and process. So going back to our not so duckish diagram anymore, let's just firstly trim out a few bits that will make the demonstration a little bit more difficult, and then apply the Gestalt law of proximity. So now you can see we've got these grouped into 3 different things. So now when you look at it, you can sort of say, oh, wow. So maybe in this process, there is intended to be more than one person performing it. So we've got a person who is actually putting in the order, we've got a person who is recording the order, and we've got another person who's actually fulfilling the order. Wow, I couldn't see that before. Well, you weren't supposed to, that's how I planned it. So we have another law, the Gestalt law of similarity. And what this means is, in a nutshell, things that look similar tend to get grouped together. So if you do something even as simple as apply a color to things, then you can see that that group of the dark versus the light items, you automatically think, oh, all those dark ones, they're, you know, something. They're a group. And the light ones, they're also a group. So we can kind of use that trick as well to circumvent the cognitive bandwidth. So applying that to our original diagram here, if we apply the Gestalt law of similarity, you get that. Okay, cool. Again, we can kind of see we've got some different roles going on there, some different people doing some different things. Excellent. But let's try and make it a little bit better. What if we do both? If we do similarity and proximity? I think that looks even better, because now you can see along the horizontal grouping, we've got the roles, and along the vertical grouping, we've got kind of like a time sequence. So we've actually, without actually adding anything, like we haven't drawn any extra lines, we haven't provided any additional context to the diagram, like put anything in there. All we've done is rearrange things and change the colors a little bit. And already the diagram has got so much more meaning just by doing a couple of really simple things. So now let's go and put the bits that we took out in. How do we deal with those? Well, for the decision bit, we could do that, but that kind of wrecks the flow a little bit. We've got it going backwards, so let's do that instead. I think that looks nicer. Huh? Now, we'll also put in the exit conditions there, but we'll give them a different color as well, because they are exit conditions. They're links to other processes, other diagrams. Cool. I think we're getting somewhere. But we can go further. Let's talk about emphasis. So we have here, this is an aqueduct, Roman aqueduct in Segovia. Yeah, in Spain. And so, you can kind of see that the Romans put a little bit of emphasis onto the aqueduct there. The little person down the bottom is a testament to how large that thing is. Now, you don't necessarily need to go that far. You don't need to make things that big. But, playing with calling things out on the diagram and showing people what they need to do with it is important. So think about, does everybody here know The Hitchhiker's Guide to the Galaxy? Yeah? On the book, The Hitchhiker's Guide to the Galaxy, what was the most important thing? What was the prime selling point? Don't panic, exactly. So we look at that and we go, okay, obviously, that's something that they wanted to draw attention to because it's big and it's printed at the top. Great. And, going back to those Gestalt law of proximity and similarity, it's kind of like when you put things together, you can also emphasize them. So like having a toolbar or a menu, you've got all the things that are together that are relevant to that particular heading. That's, kind of a form of emphasis as well. So let's have a look at this now. So what I've done here is just to emphasize the fact that those two bits on the end are exit conditions. I've given them a different shape. Okay? So you can see now, oh, there's something different with those. I should pay attention. That's not necessarily a part of what we're talking about. To make it clear where the process starts and ends, we put a little green arrow and a little red stop sign so we know that the target audience knows this is where I start, that's where I stop. And finally, just to tie it all back around, because we did actually have previously these exit conditions, they were part of the process and they had other bits and pieces as well. So we can tie those back in to say we have inputs into the start of the process, the start of the diagram. And you can do that with anything that's got inputs in there. But as you can see, you kind of read this from top to bottom and from left to right as much as possible. And now you have a diagram which is not a duck, which conveys a lot of meaning without really adding and in fact mostly taking things away from it. But visual expressiveness. I've kind of done a little bit of it. We've got some different colors, we've got some different shapes, but there are many, many things that you can do with this in order to, draw attention to or take attention away from certain elements of your diagram. So things like using different colors, different sizes, different fonts, border thicknesses, orientation, either of text or the actual elements, using images, all kinds of things. You need to experiment with this yourself to find out what works for you and what works for your audience. But always remember those rules that we talked about originally. So be consistent, know your audience, don't stick too much stuff in there. Remember, some models are useful. And if you're kind of like me and you're not really good at picking out colors, then this is a really cool resource, ColorBrewer, where if you put it to one of these map settings, then it gives you a whole bunch of distinct colors that you can use, so they won't blend in with one another, because what you don't want to do is have a bunch of colors on there, but they all blend in, and so they're not distinct. If you want these things to be distinct, then you have to make the colors kind of clashing, not complementary. So, having said that, do we have any questions? Not necessarily about that image.
Thank you very much. We will take some questions. Just a note that we are heading into afternoon tea, sorry. So if you are particularly desperate for a cup of tea, you can get up and leave, or we will continue taking questions for as long as there are some. But thank you very much.
Thank you.
Thank you for that. Just wondering what diagram software you'd recommend.
Look, I worked for a company that does some really good process modeling software. And the difference between a diagram and a process is that a diagram is just like an image on a page, but a process model is actually three-dimensional. So not only do you have your objects on your page, but you're linking those to other bits and pieces, and you can kind of cut that and slice that in any way. That's kind of my favorite tool to use. It's called Holocentric Modeler. I don't work for them anymore. I'm not paid for by them, but I do think that their software is really cool. If you can get a hold of it, try using that. If not, something like Visio. All the diagrams that I did were just done in PowerPoint, so it's reasonable. I haven't really used too many different things. I mean, I tend to use sort of enterprise scale stuff like, Sparks and Irwin and Holocentric, things like that. But whatever you want to do, these principles apply to, any diagramming or even just drawing software that you want to use. Any other questions?
Very interesting talk, thank you. I was wondering at the beginning, you said that when it gets too complex, too many elements, you try to leave some for another page, so you only display 5 to 9. How would you manage this thing of having several pages, or how would you help navigating when you have more objects?
Well, what you could do is actually label each of these diagrams. So this one might be like order coffee or something like that. And then with your entry and exit processes, so you've got serve next customer and clean cafe. So those ones, you'd have pages labeled as those. And then you only sort of show the relevant pages to the people.
Thanks. So just looking at this diagram here, could you comment a little bit on the relative benefit of using consistent conventions, like for instance, flowcharts theoretically have a formal definition of doing it. When I draw diagrams, so I teach at university, and when I'm drawing diagrams for students, I never do that. I always just draw lines and boxes like you've got here. Can you comment on when you should or should not feel a need to use those particular formal styles?
Okay, yes, I can comment because I do actually have some fairly strong opinions on this. And yeah, so the thing with something like flowcharts, or with, I don't know if you've heard of BPMN, which is business process modeling notation, those kinds of things, there is a lot of implied meaning in them. So you have to know what the box means, you have to know what the slanty box means, you have to know what the diamond means, you have to know what the 16-sided thing means, you have to know what the thing with the thing taken out means. And if you don't know, then you've actually lost a lot of the context and the meaning in those diagrams. So especially if you're doing a diagram for a layperson, keeping it as simple as possible and using only a very limited set of known and understood symbols is highly preferable to kind of formalizing it and making it overly complex. And going back to the start, that's why, you know, I said all models are wrong, some models are useful, and know your audience, because yeah, it might not be completely accurate to what's going on behind the scenes, but if it's understandable by the person that you're targeting it to, then it's vastly preferable to being technically correct. Any other questions? No? Cool. In that case, let me just quickly put up the references and attributions. They're for the most of the images are my own, but on those particular slides, they're where I got the images from. And if you want to find me, I just created a Twitter account specially for this, if you want to send me a message. I'm not really usually a social media kind of person, but you know, it's there, or I've got some business cards. You can find me on LinkedIn. If you type in that last name into LinkedIn, I can pretty much guarantee that I'll be the only one there. So.
Cool. Thanks very much, Adam.